Hey students, this is the beginning of the TRIG part of the unit. So we are going to be doing a lot in this set of notes. This is a longer set of notes. So buckle down and let's get ready to go. So hopefully you've seen part of TRIG before. The part about SOHCAHTOA has been taught in ACT prep. Sometimes it's taught in middle school, depending on how advanced your math is in middle school. Sometimes it's talked about in Algebra 1, but in geometry, this is where we're actually going to learn a lot about it. You will need your calculator. If you are using this type of calculator, you need to make sure that your calculator says DEG right there for degree. If it doesn't, you need to hit that button right there and get it set to degrees. And if you are using a graphing calculator, go to mode. And if you look down right here, it says radian and degree. Degree should be dark. You go left or right and you get on top of it and you hit enter and you know that it's selected because our calculators have to be in degree mode to be able to do trig. All right, so let's find out, what is trigonometry? Trigonometry is simply the study of right triangles. Okay, and so there are lots of real world applications that use trig in their work. Okay, so it's the study of, I said right triangle, but it doesn't have to be a right triangle. Okay, it's just the study of triangle measurements. All right, so when we have a right triangle, we have certain ratios that have been discovered and that are really, really neat the way these work out. So the trig ratios are called sine, okay, sine. When you see it, they only use the first three letters. This is not sin. Do not say sin. It is sine. We have cosine. When you have the abbreviation, it's only three letters. Do not say cos. Say cosine. And we have tangent, and again, you won't say tan, you will say tangent. Okay, the sine is the ratio. Now, we just got done with Unit 7. What is a ratio? A ratio is just a fraction. Okay, it's a fraction. It's a comparison of two numbers. So this is the ratio of the leg opposite the angle to the hypotenuse. Let's talk about this angle. In our picture, in order to do trig, you have to have what's called a reference angle. So in this picture, let's just put a little mark right here. Now we usually mark the reference angle with a little arc. Sometimes you will see a Greek letter, that's a zero with a little loopy in it, that's called theta. Sometimes they'll throw a Greek letter in there, sometimes they'll throw a variable in there. Okay, but that's what you're looking for your reference angle. Every reference angle has three parts to it. It has a side that is opposite. It has a side that is adjacent. Remember, adjacent means right next door, so I'm going to put adjacent. And it has a side that is the hypotenuse, which you should know because we've dealt with that a lot. Okay, so every angle has an opposite, an adjacent, and a hypotenuse. So the sine is going to be the ratio of the opposite over the hypotenuse. So in my picture, that is A over C. Okay, we'll come back to this one in just a minute. The cosine is the ratio of the leg adjacent to the angle to the hypotenuse. So adjacent over hypotenuse is cosine. So that would be B over C based on this picture right here. And then tangent is the ratio of the leg opposite to the angle to the leg adjacent to the angle. So it's going to be opposite to adjacent. Opposite is A, adjacent is B. All right, new color. If I change my reference angle, and let's put the orange as my reference angle B, does the hypotenuse change? No, the hypotenuse doesn't change at all. Does the opposite change? Yes, so now this is my opposite, and this is my adjacent. And you could put O, A, and H when you're labeling your pictures. O is opposite, A is adjacent, H is hypotenuse. Okay, so how that's going to change my ratios, sine is opposite over hypotenuse, that's B over C. Cosine is adjacent over hypotenuse, A over C. Tangent is opposite over adjacent, so that's B over A. Okay, so that's how we get the 6 ratios out of a picture, changing the reference angle, changing the opposite and adjacent, and writing them down. All right, look at our answers over here. I want you to draw an arrow from here to here, and then I want you to draw an arrow from here to here. There is a theorem that says, and it's actually one of our standards, that says the sine of one angle is equal to the cosine of the complementary angle. The sine of one angle in a right triangle is complementary, or excuse me, is congruent to the complement of the other angle. Ms. Kotler was telling me something about that. Let's see if I can figure that out. Corresponding complementary angles are congruent. Corresponding complementary angles are congruent. Corresponding complementary angles are congruent. So maybe sine of A is the same as cosine of B. Sine of B is the same as cosine of A. Okay, and then what do you notice about these? These are inverses of each other. They are reciprocals. Okay, so they flip. All right, let's see what SOHCAHTOA means. So you've heard it. Okay, you've heard it. So now I want to, if you've never done this before, this is going to sum everything up. So what this is called SOHCAHTOA, and this is a shortcut acronym for telling you what to do with what we did right here. Okay, sine is opposite over hypotenuse, SOH. Okay, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine, adjacent, hypotenuse. Tangent is opposite over adjacent. Opposite over adjacent. Okay, so every time we get to a new page of work, I write SOHCAHTOA at the top of my page, and I'm constantly looking to see how I'm going to set up the problem. All right, these first examples are just giving us opportunity to practice getting the ratios. Remember, a ratio is just a fraction. Okay, so all of these are dealing with angle A as my reference angle. So this is my opposite, this is my adjacent, this is my hypotenuse. So if I'm just getting the ratios, it's just a fraction answer. All right, sine is going to be opposite over hypotenuse, 5 over 13. Cosine is going to be adjacent over hypotenuse, 12 over 13. By the way, if these numbers reduce, you would have to reduce them. These don't reduce. Do y'all notice this is one of our triples? 5, 12, 13? That would help you. Can you recognize that triple? Can you recognize that triple? That's why we do that. Okay, tangent is opposite over adjacent, so 5 over 12. If I'm using C as my reference angle, this is now my opposite, this is now my adjacent. Opposite, adjacent is touching, opposite is across from. So that means sine of C is going to be 12 over 13. Well, what do you notice? Okay, and they should be the same. Cosine is going to be 5 over 13, adjacent over hypotenuse. And there's that connection. Tangent is going to be opposite over adjacent, 12 over 5. And this is the reciprocal. I'm just going to write flip. Okay, So if you get these, you can write these down without even looking at the picture. Okay, you are going to get the missing side, and then I want you to do number 2. Go ahead and get all of the answers right here using number 2, and don't forget you are going to have to reduce because this is a multiple of a Pythagorean triple. Okay, go ahead and do that. Okay, so my question to you is what was the sine of x? And you should have got 3 over, you should have got 5 over 3. Why, that was a mistake. No, you should have got 3 over 5. That's right. I'm sorry. My brain kind of did a little flip right there. They're not reciprocals. They're the same. So this answer is the same as this answer, and this answer is the same as this answer. This is the one that is flipped. So the sine of x is the same as the cosine of w. They are cofunctions of each other is what we call those. Cofunctions. Cofunctions are congruent. Yeah. I had to come up with that. I'll tell you guys in class. Okay. Corresponding angles, cofunctions are congruent, something about that. All right, we're not going to do another one because this is pretty basic. These are cofunctions, these are cofunctions, these are reciprocals, and the ACT loves to put questions on here because they will ask you about the sine of one angle and then they'll end with the cosine of the other angle and it's the same answer. Okay, turn the page. So now, this is how we apply SOHCAHTOA. Write SOHCAHTOA at the top of your paper. Spelling it is something you need to do right. Okay, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, there are 2 types of problems that we're going to set up. The first one is going to be finding a side length. Okay, to find the side length, first thing we have to do is we have to figure out, is it sine, cosine, or tangent? And then we are going to use algebra to solve for x, because the way we set up the sine, cosine, and tangent, it can be done with basic algebra to solve for x. Okay, so this is what we do. First thing I do is identify my reference angle. Then I'm going to identify the parts. Now, there's nothing right here. I don't have to write anything here. Identify the pieces that are given to you. So this is my opposite, and this is my hypotenuse. Then my eyeballs go up here, and I say, which one of these uses opposite and hypotenuse? There's only going to be one, okay, and it is sine. So watch what I do. You write down the word. An angle always has to follow the trig function, okay? So it always has to be an angle. If it's an x, that means we're finding the angle. If it's in the picture, you have to use the angle in the picture. So an angle always follows the trig, equals, what is my opposite? X. What is my hypotenuse? 19. Now, you are going to have one of 2 ways to solve this problem. If x is in the numerator, on top, all I have to do is multiply both sides by 19. Okay, because mathematically, that's how we get x by itself. Now, the neat thing about this is your calculators are programmed with all of these measurements already in there. I'm going to blow your mind. Back when I was in school, we didn't use these to do trig. Okay, like I'm getting ready to show you. We used it's in your homework. It's over here. We use these. It was a page in our textbook. And I would have to go, okay, sine of 28. So I would come down here to 28, and I would look for sine, which is the first column, and I would have 0.4695, and then I would multiply that by 19, and that would be my answer. Your calculator is programmed to do that for you, but that's what this table was for in our book. And I've given this to you in case you're ever unsure about your calculator. You have the answers for all of these. And then we're going to discover something else about the cofunctions. I'm going to show you something neat about that. But let me show you how to use your calculator with it. So you could easily Take that answer for sine of 28, which was 0.4695, and multiply it by 19, and you would have your answer. Your calculators do it for you because we have sine, cosine, and tangent keys right here. So we're going to type in exactly the way it is here, 19 times, and then we're going to put sine of 28. Now it opens the parentheses. You can close the parentheses because there's a lot more you can do with trig later in Algebra 2. Ours is going to be very basic in geometry. 19 sine of 28. We are going to round right now, unless I tell you different, to 2 decimal places. So that's going to be 8.92. 8.92. Okay, 8.92. Now, when I have that answer, I could then do Pythagorean theorem, and I could get this answer, and I could subtract this from 90, and I can get that angle answer. And if I have all the sides and all the angles, that is called solving a triangle. There's nothing else you can find in that triangle. I'm not going to make you do that right now, but if it shows up in your work, you know what I'm talking about. Okay, number 5. First thing is let's see what our reference angle is. And then we're going to label our parts. This is opposite and this is adjacent. It's not hypotenuse. This is adjacent. And then I ask myself, what uses O and A? Tangent. So we write down tangent. Angle follows the trig word, and it is opposite over adjacent. I'm going to multiply by 32. I'm going to multiply by 32. And I'm going to put that in my calculator, 32 tangent 41. 32. You don't actually have to hit multiply. It automatically multiplies. Tangent, let's say 41. Okay, so it looks like that. And we get 27.82. 27.82. Now, something you don't want to do is you don't want to type in tangent 41 times 18 like that, because it's assuming you're multiplying the 41 times 18 and then taking the tangent of it. It's not going to give you the right answer. Okay, so be very careful about that. Make sure you know that this has to be completely separate from this. Okay, number 6. So let's identify our reference angle. Let's identify our parts. This is the hypotenuse and this is the adjacent. And I'm going to ask myself what uses A and H, and that would be cosine. So cosine of 21 equals adjacent over hypotenuse. And then I always have people ask me, do I have to show this step here, multiply by 26? You don't. You can go ahead and just pick up your calculator because you're going to do enough of these that you can just see it in your calculator. I do need to see the problem set up, okay? And then you can do everything in your calculator. So 26 cosine 21, that's going to be 24.27. Okay, let's see. All right, would you do number 7 for me? Completely get your answer, please, 2 decimal places. Okay, you should have got 11.43 as your answer. So I was given the opposite and adjacent, and tangent uses opposite and adjacent. Okay, now let's change it up just a little. Let's set this one up. So my question to you is, which trig function am I using, sine, cosine, or tangent? All right, if you pick sine, you are correct. So this is my reference angle. This is opposite. This is hypotenuse. So watch what happens when I set this one up. This time it is opposite over hypotenuse. Notice up here the x was in the numerator. Now the x is in the denominator. So we have to think about how to solve this in a different way, because multiplying by x is not going to simply give us the answer. It's part of the work, but we're not done. So what I like to tell students to do is to think of this as cross multiplying. We have done lots of cross multiplying. I'm going to give you a shortcut, but I want to show you the real way. Okay, so if I cross multiply, I get x times sine of 33 equals 1 times 15. How do I get the x by itself? I can divide by sine of 33 because that's just a number. Sine of 33. It's just a number right here. Okay, sine of 33 is 0.5446. So what I'm doing is I'm dividing both sides by 0.5446. Okay, but our calculator is going to do it for us. This is what you're putting in your calculator. All right, so just like it is, 15 divided by sine, is it 33? 27.54. Okay, now I'm going to show you the shortcut. I'm going to rewrite the setup. Sine of 33 equals 15 over x. Okay, and you're going to hear me say this all the time. If x is on the bottom, we put the trig on the bottom. Okay, so I'm going to write that down. If x is on the bottom, put trig on the bottom. Okay, if x is on the bottom, put the trig on the bottom. So what did I do here when I was working this out? This is what I started with. X is on the bottom. So what I did was I moved the trig, which is this right here, to the bottom, and I just figured it out. You don't have to show me any work for that. You can just write this down, write this step down, and then write this step down, and then put it in your calculator. If x is on the bottom, put the trig on the bottom. So this is what I would write down. And then I would put that directly in my calculator. Okay. All right, let's do another one. All right, so we've got our reference angle. I've got adjacent and hypotenuse. What uses adjacent and a hypotenuse? Cosine. So it's going to be cosine of 43 equals adjacent over hypotenuse. If x is on the bottom, put the trig on the bottom. If x is on the bottom, put the trig on the bottom. Okay, and then we're going to put that in our calculator. 36 divided by cosine 43. 49.22. By the way, cosine 43, cosine is the middle column, 0.7314, 0.7314. Looky there. Now it's off just a little because these are rounded values. Your calculator is calculating it without rounding any values, but you can see that we still get 49.22. Okay. All right, see if you can do number 10 for me, please. All right, so my answer ends up being 8.12, and it is right here. So 25 divided by tangent of 72, 8.12. Not going to do number 11 because we've got enough of these. So when you have these word problems, you just have to be a visual person. So let's talk about some words that you're going to have in your word problem. Remember, vertical distance is this. Horizontal distance is this. Things that are slanted, ladder, rope, ramp, airplane flying. Okay, that, guys, I can't stress how hard it is to make students understand that when you have things that are leaning, they are the hypotenuse. Okay, this one can also be the height of something. Okay, this can be the length. The ground, if it asks you what angle meets the ground, that is right here. If it asks you what angle meets like the telephone pole, that's right there. Okay, so common sense when setting up these problems, and then the problems are just like the ones up here. Okay, so Jake leaned a 12-foot ladder, there's the ladder, against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? So this is what your problem looks like. Okay, now I'm not going to work it out. I just want to set it up because you guys have had enough practice working it out. A ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? And then, guys, I'm going to be insistent that when you draw your pictures, that there's a right angle in that picture. You are honor students, and you should be doing honors work, so make sure you know that trig cannot be done if there's not a right angle in the picture. Okay, now let's move on. Finding angle measures. So this is going to use what we call the inverse key. On your calculator, if you look above your keys, a little bit blurry there. There we go. If you look above your keys, above the sign, it says sine -1. Above cosine, cosine -1. Above tangent, tangent -1. Those are your inverse keys, and they are used to find missing angles. The regular keys were used to find missing sides. So this is going to be, let me focus again. This is going to be really easy for you once I show it to you. All right, so we're going to start off the same way. Let's write SOHCAHTOA up here. First thing, find your angle. Now this time my angle is what I'm trying to find. It's going to be represented by X. And then label your pieces. This is opposite. This is hypotenuse. Guys, it's the same thing every single time. Once you get it set up, then you have different ways of working out your problems. What uses O and H? Sine. So we're going to write sine. The angle always follows the trig word equals opposite over hypotenuse. Don't reduce. Don't put this in your calculator. Don't do anything with it. Now, in order for me to use my calculator, I have to have a number following this, the sine, cosine, or tangent. So then this little inverse method makes it happen in our calculators. Okay, so what we do is we will switch places with the x and the fraction. Okay, and when we do that, by switching those places, it now has turned into an inverse function. And it's going to be 15 over 24. You're not flipping it. You are just switching places. And that is equal to x. This is what we're typing in our calculator. So it's going to be sine. And then we're going to put 15. And you can use your ABC key or you can use divided by. On this calculator, I have to use divided by. But if you use your ABC key, it's going to work out the same. Oh, I forgot inverse. So sorry. Second sine. There we go. And see how it puts the little -1 to show you just like what you're typing is the same as what's on your paper. And then 15 divided by 24. And we hit enter. Now, this is an angle measure. In the math world, they like angle measures to be rounded to the nearest whole number. If you forget, and they even put tenths on this worksheet, but I like whole number. Okay. If you forget and you put tenths, I'm not going to count it wrong, but my answers are going to be whole numbers. So this is going to round to 39 degrees. Okay. X, and you guys know that when you're rounding and it's approximate, I am rounding up to 39 degrees. Technically, we should be doing this on everything that we round, but I like doing it particularly on this because it's not 39 degrees. It was 38 point something. Okay, but this is the process. It's super easy for us to figure out. All right, number 2, here is my angle. This is the adjacent, and this is the hypotenuse. So we're going to say cosine of x equals adjacent over hypotenuse. I'll show you in this calculator just so you can see that the work can be done with your ABC key. Okay, so we're going to do the switch, and I'm going to say cosine inverse of 8 over 11 equals x. So we're going to go second cosine, and this calculator also puts it on the screen. And this time I'm going to use my ABC key. Okay, so I use my ABC key, or you can use the divided by key. And that gives us 43.3. So I'm going to say 43, whoops, it should be approximate to 43 degrees. Okay, again, if you give the decimals, that's perfectly fine. Okay, if you give the decimals, but I want you to try to remember, it's just you always see whole numbers inside the angles and you see decimals on the outside. Okay, all right, number 3, go ahead and set that up for me. Show me that you can do it. Okay, should have used tangent. Tangent of x equals opposite over adjacent, which is 20 over 37. I did the switch, change to inverse. Switch, change to inverse. Put this in your calculator. It's about 28 degrees. Okay, I can't make this any harder other than the fact that you might have radicals on the sides of the problems and that you may have to deal with simplifying some radicals before you put those into your calculator. Okay, so let's just do one more just to make sure you got it. Let's do number 6. Here's my reference angle. This is opposite. This is adjacent. So OA is tangent. Tangent of x equals opposite over adjacent. I am going to write the inverse is equal to x, doing the switch, and I'm going to put that in my calculator. I think I forgot my -1, didn't I? There we go. Second tangent, so the inverse tangent of 7 over 5. Sorry, that looks like 17. 7 ABC 5. And we get 54.46, not 55, 54 degrees. Okay, 54 degrees. All right, let's flip over to the next page. Now, the next thing we're going to talk about is angle of elevation and angle of depression. So TRIG can be used on a daily basis in the workplace. Since trigonometry means triangle measure, any profession that deals with measurements deals with TRIG as well. Carpenters, construction workers, engineers, for example, must process a thorough understanding of trigonometry. That's why they take a lot of math when they're in school. Okay, so angle of elevation is always measured from the ground up. So if you are like where it's kind of weird. You have to pretend that this is your line of sight, which means your eyeballs might be on the ground, but everything typically starts on the ground, and so we're going from the ground up. The angle of elevation is always measured from the ground up. Think of it like an elevator that only goes up. It's always inside the triangle. Do you see that? That is called the angle of elevation. In the diagram at the left, X marks the angle of elevation from the top of the tree. Hear that? The angle of elevation from the top of the tree. That still means you're looking up to it. Sometimes it'll say to the top of the tree, of the top of the tree, but it is still seen from a point on the ground. You can think of the angle of elevation in relation to the movement of your eyes. You are looking straight ahead, and then you raise your eyes to elevate them to see the top of the tree. Okay? All right, angle of depression. The angle of depression is always outside of the triangle. If you look at this picture, this is the triangle where we would be doing our math. Okay? So if I was going to look at the angle of depression, remember it's from a line of sight. And then I want you to think of it as looking down. You're at the top of the lighthouse and you are looking down. So I want you to see the arrows that I have put in these two pictures. This is from the ground looking up. This is from up high looking down. And it is on the outside of the triangle where we would do our math. Okay? So the angle of depression is always outside of the triangle. It is never take that word. It's not on the inside of the triangle initially. You can think of the angle of depression in relation to the movement of your eyes. You're standing at the top of the lighthouse, looking straight ahead. You must lower or depress your eyes to see the boat in the water. Now, there are two possible ways to use our angle of depression to obtain an angle inside the triangle so that we can do our work. There's two methods. First one is, this is making a right angle in this corner. So I could say that this angle's 35. This is my angle of depression, and I know that this is complementary to it, so 55 would be the angle I would use in my work. The other method, which is the method I use, is that you have your line of sight here, you have your line of sight here, and line of sights are perfectly horizontal, and they are parallel. So the name of these angle pairs right here are alternate interior. So we do have alternate interior angles that are congruent. Okay, so because they're congruent, we can think of our angle of depression as being the same as our angle of elevation. Okay, so if you write it up here, you can also write it down here. I will be using alternate interior angles in my work. Okay, just so you know. You could also use this triangle to get your work, because whatever this measurement is the same, and whatever this measurement is the same, because we typically have made a rectangle. Okay, so keep that all in mind as we're doing our work. Okay, example number 1. This is all about drawing your picture, and then the work is the same. From an airplane 6,000 feet above ground, you see a landing strip at an angle of depression of 24.5. Okay, so watch. All right, from an airplane that's this high in the ground, I'm going to do this because you see a landing strip that's down here at an angle of depression of 24.5 degrees. That is the correct way to draw that picture. Measuring the distance along the ground, how far are you from the landing strip? Measuring the distance on the ground, how far are you from the landing strip? Round your answer to the nearest hundredth. Okay, so that means I can put the 24.5 degrees here because they are alternate interior. I'm going to ask myself, what trig function am I using? So this is opposite. Oh, what did I tell y'all? There we go. Right triangle. This is opposite, and this is adjacent. Okay, so what uses O and A? That would be tangent. So tangent of 24.5 degrees equals opposite over adjacent. All right, so your question is, am I going to multiply, am I going to divide, or am I going to inverse? Okay, x is on the bottom. If x is on the bottom, put the trig on the bottom. If x is on the bottom, put the trig on the bottom. So 6,000 divided by tangent 24.5. And we get 13,165.798, so that's 0.80. So we get x equals 13165.80 feet. Okay, and on an airplane landing, that makes sense. Okay, so that is your answer. All right, so would you do, let's see. Well, let's show you angle of elevation. If I were to draw this picture. All right, from a point on the ground 25 feet away from the foot of a tree, so my tree would be right here, the angle of elevation of the top of the tree is 32 degrees. Find to the nearest foot the height of the tree. Okay, so what uses O and A? By the way, tangent is the most popular trig function to use in real world problems. So tangent of 32 equals opposite over adjacent. And my question to you is, am I going to multiply, divide, or inverse? I'm going to multiply. So 25 tangent 32, 15.6. So 15.62. 15.62, and it says to the nearest foot, 15.62 is going to be x is approximately 16 feet. Okay, go ahead and do question number 2. Let's see if you can figure it out. All right, so this is what your picture should look like. We've got a lookout spots a fire from a 32-meter tower. The angle of depression from the tower to the fire is 13 degrees. So that means the 13 can also go here, right triangle. How far is the fire from the base of the tower? So guess what? Tangent again. So tangent of 13 equals opposite over adjacent. If x is on the bottom, put the trig on the bottom. (138.61 feet or meters? X equals 138.61 meters. Okay, so we're going to move on. I just want you to know the trig, I will help you set up the problems. If you need help, it's the same thing. So let's go and finish this section right here. It says refer to the triangle below. What is the relationship between the measure of angle A and the measure of angle B? They are complementary. All right, what is the cosine of A? Cosine of A is adjacent over hypotenuse, which is 12 over 13. What is the sine of B? Sine of B is opposite over hypotenuse, which is 12 over 13. So this is kind of reinforcing the fact that these are cofunctions. What is the sine of A? Sine of A is opposite over hypotenuse, 5 over 13. What is the cosine of B? Cosine of B is 5 over 13. What do you notice about the cosine and sine of complements? They are the same. They are equal. The sine of an acute angle is equal to the cosine of its complement. The sine of an acute angle is equal to the cosine of its complement. Sine and cosine functions are called cofunctions. All right, so mathematically, this is what they look like. Cosine of x is the sine of the complement. Sine of x is the cosine of the complement. Notice the connection between the letters C and O. Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. And then you have the word complementary. Okay, so any trig function of an acute angle is equal to the cofunction of its complement. That's the CO. Okay, the cofunction of its complement. Cofunctions of the complements are congruent. Cofunctions of complementary angles are congruent. Cofunctions of complementary angles are congruent. Okay, cofunctions of complementary angles are congruent. All right, find the value of sine of 30. We're just going to type that right in our calculator. Find the value of cosine of 60. Notice 30 and 60 are complementary, and notice they get the same answer. Also in the table, you can see that in the table that I gave you. Okay, so 0.5, 0.5. You can use your calculator to check your answers once you check these. So 15 and 17 is 90, so I know these are equal. It's just asking you what would it equal. So cosine of 8 degrees would be equal to the sine. And if you go 90 minus 8, of 82. 8 degrees, cosine of 8 degrees, 0.9903. Sine of 82, 0.9903. See how they're equal? They're cofunctions. Okay. Sine of 43 is the same as cosine of 47. All right, last question. What is the cosine of 17 equal to? This last question. And you should have got sine of 73. These add to 90, and they are cofunctions. Sine of the complementary cofunctions of complementary angles are congruent. They're equal to each other. All right, that is all the notes. You have your packet. It is a big packet, and you have lots of problems to do. So you will have lots of practice with this. Okay, so this will be the next worksheet that we start on in class. Thanks, students.